Alright, lesson number 26, March the 15th through the 19th. Make sure you have this lesson out in front of you. Alright, so let's go ahead and look at this. We're going to solve rational equations. Alright, so it says solve the following equation for x and give evidence that your solutions are correct. Alright, so let's go ahead. How would we do this? Well, I would need to find a common denominator. I have 2, 3, and 6. So I'm going to use 6 as my common denominator. So 2 times 3 is 6. So 3 times x is 3x. 3 times 2 is 6. 2 times 1 is 2. And 6 times 1 is 6. So 1 times 5 is 5. Alright. So let's go ahead and look at this. If I multiply everything through by 6, alright, if I multiply everything through by 6, my 6's canceled by division, because 6 divided by 6 is 1. So I end up with 3x plus 2 is equal to 5. Subtract 2. 3x is equal to 3. Divide by 3. X is equal to 1. How would I prove that? Well, I could look at it like this. 1/2 plus 1/3 is equal to 5/6. Well, I know that this is 3/6. I know this is 2/6. So that gives me 5/6. Okay? So I know it's valid. Alright, look at the next one. 2x ninths plus 5 ninths is equal to 8 ninths. Once again, I have a common denominator, so I can go ahead and multiply through by 9. Alright. So, therefore, when I do that, I get 2x plus 5 is equal to 8. I'm going to subtract 5. 2x is equal to 3. Divide by 2. So I get x is equal to 3/2. Okay? So then I would plug that in. So 2 times 3/2. Alright? 2 times 3/2 is 6/2 or 3. So I have 3 ninths plus 5 ninths is equal to 8 ninths, which shows me that it is a valid solution. Okay? 2 rational expressions with the same denominator are equal if the numerators are equal. Okay? So we now know how to add, subtract, multiply, and divide rational expressions. We're going to use some of those basic operations to solve equations involving rational expressions. Let's go ahead and look at example number 1. Solve the following equation. X plus 3 over 12 is equal to 5 over 6. So I can do common denominators. Okay? So let's go ahead and look at common denominator. 6 and 12. I'm going to use 12 as my common denominator. My first fraction did not change, so it's x plus 3. 6 times what is 12? 6 times 2 is 12, so 2 times 5 is 10. Alright. At this point in time, I can multiply through by 12. When I do that, 12 divided by 12 is 1. 12 divided by 12 is 1. So I get x plus 3 is equal to 10. Subtract my 3. And I get x is equal to 7. Alright, so we see that our solution is 7. There is a second method that you can use here. And really it is the same thing. I'm just showing you the simplest way. So, if you have trouble with this, just let me know and we'll see if the other ways work. but I won't spend a whole lot of time showing that method to you because, like I said, I'm trying to show you the easiest way to do it. All right, look at it, number 3. Solve the following equation. 3 over x is equal to 8 over x minus 2. All right. So we're going to go ahead and convert both expressions to equivalent expressions with a common denominator. So looking at this, I know my common denominator is going to be x times x minus 2. All right, so with that being said, I know 3 is going to be have to be multiplied by something. So I have an x here and I have an x here. What is the only thing I'm missing from my new denominator? And that is x minus 2. All right, look over here. I'm going to go ahead and copy that 8 down. I have x minus 2. The only thing I'm missing here is the x. So I have this. So I'm going to go ahead and multiply through. 3 times x is 3x. 3 times negative 2 is negative 6. 8 times x is 8x. All right, and now I can look at it like this. All right. Since the denominators are equal, I can multiply through by that denominator. And when I do that, they cancel. So therefore, 3x minus 6 is equal to 8x. I'm going to subtract my 3x. So I get negative 6 is equal to 5x. Divide by 5. X is negative 6/5. Okay? So it is a solution. All right, let's look at exercise 4. All right, solve the following equation for A. When I have 1 over a plus 2 plus 1 over a minus 2 is equal to 4 over a squared minus 4. Guys, I'm going to treat this just like I have been my equations. I get 1 over a plus 2 plus 1 over a minus 2 is equal to, I'm going to factor this a squared minus 4. It's the difference of two perfect squares. So therefore, I'm going to factor it as a plus 2 and a minus 2. All right, so look at my common denominator. I have an a plus 2. I have an a minus 2. So my common denominator is going to be a plus 2 times a minus 2. All right, so my numerator for my first fraction is 1. Let's look at the first fraction. I have a plus 2. The only thing I'm missing is the a minus 2. So I have to multiply. Second numerator is 1. I have a minus 2, so the only thing I'm missing is the a plus 2. So I got to multiply. Over here, notice I have everything in my denominator, so it stays the same. Since I have common denominators, then I know I'm going to go ahead and multiply through. So a minus 2 plus a plus 2 is equal to 4. Go ahead and combine like terms. 2a, 2's cancel out, is equal to 4. Divide by 2, and you get a is equal to 2. Okay, now, here's what we have to notice. It tells me a is equal to 2. If I put 2 in there, what's going to happen? I'm going to get a 0. And anything times 0 is 0. I'm going to end up with zeros in my denominator. Can I do that? I cannot. So therefore, this has no solution. because A cannot equal 2. Alright, so we have what we call extraneous solution. An invalid solution that may arise when we manipulate a rational expression is what we call an extraneous solution. This is a value that satisfies a transformed equation but does not satisfy the original equation. So this worked. A was equal to 2, but I cannot put 2 back into my original equation. So this is what we call an extraneous, it's right here. I was going to write it, but it's right there. An extraneous solution. Alright, so it says solve for the following equation. Remember to check for extraneous solutions. Alright, so let's go ahead and look at this. What is the one thing that we know x cannot equal? X cannot equal 0. If I put a 0 in there, then I'm going to have a 0 in my denominator, so I cannot do that. Alright, so with that being said, let's go ahead and solve this. I have 3x, I have 4, and I have x. Find a common denominator for 3 and 4. That would be 12. And I'm just going to bring down that x. So my common denominator would be 12x. So 3 times what is 12? That's 4. So I need to multiply that times 4. 4 times 3 is 12. And I also need to multiply that times x because I don't have the x there. Now I have the x here, but I don't have the 12. So I need to multiply the 3 times the 12. So because I have like denominators, I can go ahead and multiply through. So I have 16 plus 15x is equal to 36. Go ahead and subtract. So 15x is equal to 20. Alright, divide by 15. So x would be equal to 4/3. So it's valid because the only thing that x cannot equal is 0. Go ahead and look at number 6. Solve the following equation. Remember to check for extraneous solutions. Alright, so first thing we know is b cannot equal, it cannot equal -3. B cannot equal 3. Alright, can't be that. Alright, so let's go ahead and I have 7 over b plus 3 plus 5 over b minus 3 is equal to 10b minus 2 over, and I'm going to factor this into b plus 3, b minus 3. So I see my common denominator is b plus 3 times b minus 3. Alright, so let's look at this. 7 is going to have to be multiplied by b minus 3. 5 is going to have to be multiplied by b plus 3. And 10b minus 2 does not have to be multiplied by anything because I have the full denominator. Common denominator tells me that I'm good. I can just go ahead and look at the top. So I'm going to factor through. So 7b minus 21 plus 5b plus 15 is equal to 10b minus 2. Combine my common like terms. So I have 12b minus 6 is equal to 10b minus 2. Subtract 10. I get 2b minus 6 is equal to -2. Add 6. I get 2b is equal to 4. B is equal to 2. Alright? So 2 is a valid solution since the only thing b cannot equal is -3 or 3. Alright, let's look at the last problem. I'm going to go ahead and factor this first. 1 over x minus 6 plus x over x minus 2 is equal to 4 over, let's factor this, x and x. I need to do 6 and 2, negative, negative. Alright, so my common denominator is x minus 6 times x minus 2 plus x minus 6 times x minus 2 is equal to x minus 6 times x minus 2. Alright, so 1, I have x minus 6, so I've got to multiply it times x minus 2. X, I have x minus 2, so I need to multiply that times x minus 6. And this one's not going to change because I already have everything in the denominator. So let's go ahead. I get x minus 2 plus x squared minus 6x is equal to 4. Alright. I'm going to bring everything to the left side. So I have x squared. I have minus 5x minus 2 is equal to 4. I'm going to subtract that 4 and set it equal to 0. The reason being is because now I can factor it. X and x. I'm going to subtract my factors of 6 to get 5, so 6 and 1. Alright, so here we forgot to say that x cannot equal 6 and x cannot equal 2. Alright. So now I can set x minus 6 equal to 0. So x will be equal to 6. And x plus 1 is equal to 0. So x is equal to -1. This is the only solution because x cannot equal 6. So therefore, x is equal to -1 is my only solution. Alright, since I cannot put in a 6. Alright guys, that's the rest of the lesson.